Alright, so today we're going to look at some strategies for handling concurrent connections in a custom web server written using the Zig standard library. I showed a minimal example of writing such a web server in the last video I did. Here is essentially that code with just a couple small changes to how we're handling error handling, but that's not a big deal. Now, if we go over here and we run Apache Bench on it, we're going to do 10,000 total connections with 1,000 concurrent connections. And we see it actually runs incredibly fast. The longest request that it took for us to run was 19 milliseconds. That's nowhere near bad. And this is just entirely single-threaded. Now, the problem with that, though, is this is just a Hello World server. This is not doing any meaningful work. So the next thing we're going to do is look at what this looks like if we are actually doing some work. So we are going to call this function, which is called do some work. All this is going to do is sleep for 1 millisecond. So this is going to sleep for basically the minimum amount of time that we can, and we'll see what happens. Okay, we're going to run this again with Apache Bench. And as you can see, this is much slower. In fact, there's a good chance that it just hangs. Oh, is it gonna do it? Oh no, it hung. Oh, yep. Okay, so let's dial this way back and see what we can get. Might have to restart the server actually, which is fine. Let's restart that server and run that again. Okay. And we can see that even though we're only waiting for 1 millisecond per thread, the amount of time that each request is going to take is going to massively increase. And if you're doing any real work, chances are a connection is going to take longer than 1 millisecond to do whatever real world work you need to do. So, what are we going to do to solve this? We are going to handle these connections asynchronously instead of synchronously. Specifically, we're going to use concurrent connections via a group. So we have the same do some work function here, but we've added a group from standard.io.group. We're going to defer canceling the group. That's just cleanup for when we're done. And then we've moved the actual response into its own handler. Every time that we every time we accept a connection, we're going to dispatch that out to that group. And then the handle connection is just going to do the same thing that it was doing before. Back over to our good Apache Bench. We can see that we are back in the realm of where we started, which is just plain awesome. Now, that's great and all, but there's a problem here. By default, group doesn't limit how many connections it can handle at once. And also by default, we're going to be using the threaded runtime that the standard library provides, which could create some issues for us. Let's look at what happens if we are, say, in a memory-constrained environment. So here we've got the same program, but now every time we do some work, we're going to allocate a kilobyte of memory. Now, I have started the server with a U limit of 2 gigabytes, which running 1,000 connections, or running 1,000 concurrent connections, 10,000 total connections, we are going to almost immediately run out of memory here. So, what are we going to do to save ourselves? So, Group itself does offer some ways to limit concurrency by changing some of the settings inside the threaded I/O implementation, which we can then catch to determine what we want to do with it. But instead, what we are going to do is just add one thing, and that is a semaphore. So a semaphore is essentially an integer with a mutex, which means it's thread safe. We can increment and decrement it, and then we are going to wait until we have room to grow before we actually handle a connection. So down in our while loop, we're going to wait for the semaphore to accept a new connection. We're then going to run our connection, which we're now passing the semaphore. We're going to defer a sem.post here, which is going to decrease the connection count that we're working with, which means we will only have 100 concurrent connections going at a time. So if I come and run this now that we've got that semaphore in place, we can see now we handle it just fine. Our speed is relatively decent, and we're not hitting out of memory. Now, this is just a start to optimizing a server so that we can handle lots of connections simultaneously, and we're still only doing simulated work. But I think that this is a good demonstration of the kinds of things that you would want to do as you're writing a web server, the kind of things that you need to consider. Anyway, thanks for watching, and I'll see you next time.